Hello everyone, this is Tuana from Llama Index and I work in the developer relations team there, and today I'm going to be talking all about text to SQL. This presentation is mainly going to focus on open source Arctic models, which allows us to generate SQL from natural language text, and I'm going to be looking into how we can use that model with LlamaIndex agent workflows. The way this is going to go is the following. We'll first have an introduction into text to SQL. We'll also discuss why we even talk about text to SQL in the first place. Then we will have a look into some examples with Arctic Text2SQL R1, which is an open source model by Snowflake. Then we'll have a very, very short introduction to agentic workflows with LlamaIndex, because most of this talk is going to center around some live coding. So I'll switch to my code editor and we will build our agent together. So what is text to SQL and why do we even care about it? Well, the answer to that question is pretty expected, I would say. And it's simply because users want to ask questions in simple natural language. However, sometimes the answers to those questions are in databases that expect something different to natural language. And especially if those questions are a bit more complex, we need to be able to do multiple steps. We need to be able to retrieve the relevant context from that database. And when it comes to SQL, that often means retrieving the relevant table in the first place, and then having a look at the schema. We also need to be able to work with the shape of that schema to generate the correct SQL to be able to retrieve the answer for that user. So that's actually quite a lot of steps. And let's look at an example as to what we even mean, what we want to get to when we talk about all of these various moving parts. So in this talk, I'm going to be showing you how to work with some example data we have. You will have access to all of that data and the code base at the end of the talk. But one of the tables we have is a table all about the 1972 Academy Awards. I've printed out the shape of this table here, and you can see we have 4 fields: award, category, nominee, and result. And I've also printed out some examples of the content in this table. Here we have various nominee names, what category they won or lost certain awards for. And let's assume this table exists and a user simply has the question, who won the Best Director Award in 1972? The problem is that this particular database is expecting something that looks a bit more like this. This is a SQL query. Some of you may be very familiar with SQL queries, some of you may not be, but the idea is it shouldn't matter. Here we have a SQL query that basically directly translates into the natural language question you saw earlier, and it's simply asking to select nominee from the name of the table, where the category is Best Director and the result is 1. So what we want to achieve with text to SQL agent workflows is a way to get from this to this with no human intervention. We're actually going to be taking it a step further, in that once we do receive the answer from our SQL database, we also want to generate a human response rather than just simply providing an output from that database itself. Why do we even care about this? I think we answered this question slightly at the beginning, but I think the best about this is that it democratizes data. What do I mean by that? It means that data is now accessible by non-technical users. It can also scale data analysis across organizations which may have different levels of technical ability. It eliminates manual SQL writing and debugging, which is great even for technical users. And it reduces time from question to insight. And what I mean by that is from the moment you conceive a question, it allows you to simply go ahead with that human question without having to bother with the intermediate steps of finding the correct table, creating a SQL query for it, receiving the result, and then also explaining that result to yourself or others. So let's have a look at an example with the particular model in question. Again, this is an open source model by Snowflake. It's called Arctic Text2SQL R1 7B. And I actually ran this query just a moment ago before we started this presentation. And it's the same exact query that you have been seeing earlier, who won the Best Director category in the 1972 Academy Awards. And it was a pretty long response we got from this model, so I did summarize it slightly. But the few things that you should notice here is that a few SQL code blocks have been generated by the model. The model goes through various steps, and the final response has sometimes blocks of thought, and the model tries to better the results as it goes along. So our challenge when we use this model is going to be retrieving the best SQL response that it has generated and running that against our existing SQL database. So this is not the entire tech stack that we'll be using, but it's definitely the most relevant. We're going to be going through a few steps when we create our agent. And the first one is going to be actually to do with embeddings. So we have multiple tables, and we want to be able to retrieve the most relevant table to the user's query. To do that, we're going to do some steps before we even start the agent workflow, and we're going to create some summaries and descriptions of each table we have. And once we have those, we're going to embed them with another open source Snowflake model, which is Arctic Embeddings. Then we'll use a text-to-SQL model that we've been discussing. This can be a relatively large model, so I have opted to use Llama to serve the model locally. You can use it via Hugging Face. And then finally, we're going to be using LlamaIndex workflows for the final orchestration of the agent step. So before I start talking about LlamaIndex workflows, I want to give you a quick recap on the entire LlamaIndex ecosystem and all of the tools available to you. So LlamaIndex consists of two main groups of products, and we're going to be focusing on the middle layer that you see here. This is our open source agent framework. You can use it with Python or TypeScript. You simply have to pip install it, and then you have a bunch of predefined tools and integrations ready there for you to create your own agent workflows. We do also have Llama Cloud. Llama Cloud, you can think about more like an agentic document toolbox, and it consists of connectors to various data sources, parsing, which allows you to parse complex layouts and files into a format that a large language model may understand, extraction, which allows you to extract specific fields from that data, and then finally indexing and retrieval. But again, we're going to be focusing on the middle layer, and specifically, we're going to be focusing on LlamaIndex workflows. This is going to be a very, very quick introduction into LlamaIndex workflows, and as you can see, it is very simple, actually. A workflow is a class that you can extend and customize to your will, and there are two main components to a workflow, if you ask me. One is the function that we decorate as step, and two are events. You can create custom steps, and most importantly, you can create custom events. And this is how it works. A step may subscribe to an event, which effectively means that when that event is emitted, either by the workflow or the outside world, that step is triggered. So in this case, when the start event is emitted, step 1 is triggered, and we run step 1. And step 1 can emit one or more events. In this case, it's only emitting a single event, which is first event, but it could emit one event or the other, which allows us to actually have workflows that branch out, so we can even design decision steps. Another great thing about LlamaIndex workflows is that you can visualize them, and that's exactly what I've done for the LlamaIndex workflow that we'll be creating for text-to-SQL. And at the end of the day, this is the exact sort of layout architecture of workflow that we'll have. When we have a start event, the first thing we will do is retrieve tables, the most relevant tables. When we have those tables, then we will emit an event called generate SQL. Generate SQL event will trigger generate SQL, which will mean that we now have a SQL query. And finally, and this is the one that we haven't really discussed, we will emit an event called SQL to natural language, which will trigger an event, a step called generate response. In this particular step, we will be using an OpenAI model to look at the response from the SQL query and try to create a more natural human-sounding response given the data. All right, so with that, I am going to switch over to my editor and let's have a look at what's going on. All right, so one step that we haven't really discussed so far is how we even create descriptions for specific tables. I'm not going to be walking through this code in detail. This is where we also use an OpenAI model. Here we're using GPT-4o Mini, and we have a bit of an instruction for the model. It says, give me a summary of the table with the following JSON format, and we're asking for a name and a table summary. And if we were to look at the table that we saw earlier, this is what we result in. We have these JSON objects that lists the name of tables and a short summary of those tables. And we have, as you can see, many, many, many tables. The next thing we want to do is we want to put this information into a SQL database. And what we'll be doing is we'll also be using Snowflake Arctic Embed L to actually embed this information. And we will be populating a retriever, and we're calling it the object retriever that has both the descriptions, the names, and the embeddings that represent those in a database. All right. Next, we have some helper functions that, again, I'm not going to go through in much detail, but they're going to help us extract the SQL query from the large response that we get from Arctic. We will also have a helper function that allows us to convert the schema, the description, and the name of the table into a string that we can embed into a prompt. All right, so this is where we will start. We'll be using two models. As I mentioned, I'm using Llama, and there's been a user that put up the Arctic Text2SQL on Llama, which is really handy. And I'm going to call this my SQL LLM. And then finally, later on, I'll also be using an OpenAI model to generate a more human-sounding response to the query. In LlamaIndex, we have a few prompts that are there as utility prompts that you can use if you like, or you can completely customize. But one of those prompts that we'll be using is this default text-to-SQL prompt. As you can see, this is a pretty long prompt that is instructing a large language model as to how a SQL query should be generated. And it expects two things. It expects a schema from the outside world. It also expects a query string from the outside world. So we could replicate what we want to achieve here. Let's assume we want to ask the question, who won the Best Director category in the 1972 Academy Awards? And here I've started off with an example where I'm basically cheating. This is not a workflow yet, but I have got a string here called Academy Award Table. It has the name of the table, it has the schema of the table, and it also has the description of the table that we saw earlier. I'm then augmenting my prompt, the default text-to-SQL prompt, with all of this information. I can then print out the final query that I want to send to my SQL LLM, and then I'm going to also be printing out the response that I get from that LLM. The way I do that is I have a chat with my SQL LLM where I'm sending it the text-to-SQL prompt, which I've augmented with the schema and the query from the user. And at the end of the day, I get something that looks a bit like this. And you may remember this from the slide deck earlier. We have various SQL blocks, and I want to be able to extract one of those blocks and forward it to my actual SQL database. All right, let's start off by defining our workflow. The first thing we want to think about are either the steps or the events of the workflow. My workflow is going to be consisting of two specific events. One is going to be called the generate SQL event, and the generate SQL event will have the table schema and context, which will be retrieved given our embeddings, and also the user query. The next event I want to have, because in an ideal world, given this event, we now have a successful SQL query, is going to be to create natural language responses from that SQL query result. So for that, we want the, again, query from the user and the SQL query. All right, I'm going to be calling my workflow the text-to-SQL workflow. And I have a few things here. You'll notice that I've got the object retriever. This is going to be the retriever that uses the embeddings from Snowflake Arctic. Next, I have my text-to-SQL prompt, my SQL retriever, SQL LLM, response LLM, and so on. The first thing we want to do is we want to be able to trigger a step given a start event. A start event is a specific kind of event. You can customize it, but a start event is usually an event that has a user query in it. And what I'm going to be doing is, given the user query, I'm going to be retrieving the most relevant tables from all of the tables I have available. And once I have those tables, I'm going to be using my helper function called getTableSchema and context. And that is going to allow me to populate generate SQL event. This generate SQL event is now going to be forwarding the query and the schema and context over to my next step called generate SQL. Now, as you can see, we're using the same exact large language model with the same exact steps as you saw before, but instead of me manually putting in the schema and context, I'm going to be retrieving the most relevant schema and description from my object retriever, which I then can use as a foundation for my SQL LLM.chat. Once I'm here, I now have a final SQL response. We'll be printing out all of these steps as we go along. And finally, we'll be able to trigger an event called generate response. And this generate response will query an OpenAI model to look at the response, which is, again, in a SQL response format. And given the user query, it will generate a human-sounding response. This is the final step of our workflow, which emits, again, another special LlamaIndex workflow event called stop event. And similar to a start event, you can use it as is, or you can customize it. In this particular case, I've opted to customize it because there are a few things that I'd like to be able to access once the workflow has finished. So instead of just having a stop event with the response from my large language model, I have decided to include the SQL query that was generated as well as the rows that were retrieved from any given table. And that way we'll be able to observe exactly what happened along the way. All right, so I'm going to be initializing this workflow. And then, although I have the response here, let's try running the same question as you saw before. And again, because my stop event is a custom one, I'll be able to access the SQL query, the rows, and the final response. So let's run who won Best Director category in the 1972 Academy Awards. I've opted to run this workflow in verbose mode, which means that we're able to see all of the steps that was triggered and all of the events that were emitted. All right, so we did get the SQL query that we were expecting. It says select nominee. It says from this particular table where the category is best director and the result is 1. As you can see, we have rows that were retrieved, and we can have a look at the content of those rows and exactly which table they come from as well. And finally, and this is the important one that we didn't really talk about when we were looking at the slide deck, you can see that we don't have a simple SQL table response. We have a natural human language response. The winner of the Best Director category in the 1972 Academy Awards was William Friedkin. I hope I'm pronouncing that correctly. All right, let's try a few more. As you can see, we have many tables here. So in this particular case, we're going to attempt to ask a question that should be accessed from a completely different table. As you can see, I have run it earlier, but I'm going to try it again. There is a table called Italian Political Leaders Term Dates. And let's run this. And again, we're in verbose mode, so we can see all of the steps that are being executed. And there we have it. All right, this particular question is actually sometimes a question that we may have difficulty with. And maybe before I point out what it is, let's have a look at the correct response here. Again, this was me executing it earlier. And the response is the notorious BIG was signed to Bad Boy Records in 1993. Now, let's try running this and see if we hit a particular problem here. And if we do, I'll explain why. And if we don't, I will still explain why. And in this particular case, if we do hit this particular problem, there are ways to, this we have, there are ways to go about it. And the main issue here is that this is a very particular name, which unless we spell exactly correctly, and in this case you can see that the G is not followed by a dot. However, in the interim, when the LLM was generating a query, it assumed that because there are dots here, there must be a dot here. This might be a human error. It added the extra dot, as you can see here, which resulted in a problem. Now, to navigate these sort of issues, what we can do is actually to make sure that we add, in some cases, another step or a reflection step where the workflow may loop back, check that the generated SQL query shouldn't be maybe generated another way by checking the contents of the selected table, in which case we would have solved this issue by checking whether this even existed or something similar to it existed and making sure that we don't have the final dot at the end. Now let's try run it, because sometimes this does work, but this is an example of where you might want to make sure that your agent workflow has slight more customization within it. All right, let's leave that one there. With that, I'm just going to do a quick recap of what we have seen so far. We've built a workflow that does the retrieval of the most relevant tables, the generation of a SQL query. Once received, we also convert the SQL response to a natural language human response. As a reminder, the entire tech stack that we've used is the following, barring the OpenAI model, which you can switch up to anything else if you like. We use Snowflake Arctic embeddings to embed and retrieve the most relevant tables. We use the Text2SQL R1 model, again by Snowflake, to generate the SQL queries. To run this model, I've opted to use Llama. And finally, we've used LlamaIndex workflows to architect the orchestration start to end. The QR code that you see at the bottom right should take you to the repository where you can find the entire code, as well as any instructions you might need to set up. And with that, thank you very much, and I hope you enjoyed that.